Hi, in this video we will talk about automatic conflict detection and resolution in our Oracle Goldengate. As we all know, Goldengate is a product that helps in replicating data across databases. In a bidirectional replication, data from site A will be replicated to site B, and data from site B will be replicated to site A. Please note that both the sites are open for read and write. Site A might have its own set of DMLs happening, and site B will also have its own set of DMLs happening. And with the help of Goldengate, we are replicating the data. We want to ensure that the data across the sites is consistent, but there might be a situation where a concurrent DMLs might be happening, and if concurrent DMLs happen, we want to ensure that data is consistent across the sites, and for that automatic conflict detection and resolution helps. Please note that there are certain criteria that needs to be followed to have this feature enabled. First thing is you can only have it for Oracle to Oracle, and the replicate must be an integrated replicate. And in order to set this, we don't have to do anything at the application level. We simply have to make use of a procedure that enables a few changes for the tables, and we need to enable or execute this procedure at each site that is involved in the bidirectional replication. So imagine we want to enable automatic conflict detection and resolution for a table DEPT1. Then we need to execute this highlighted procedure on both sides. Site A, we need to run this procedure specifying begin DMMS underscore Goldengate adm.add auto CDR schema name and then the table name DEPT1. And this flag record conflicts, we are just adding it to see what happens in a conflict and who is going to win and who is going to lose in a conflict. To be able to see that thing, we are adding this records conflict flag. So we'll have to run this procedure on site A and also on site B, specifying the schema name and then the table name. And then what happens when we run that procedure is, imagine we are running it in for site A, and the GG user 1 and the table name is DPT1. GG user 1 and the table name is DEPT1. When we run this procedure, what happens is it adds one more column to that table. It adds one more column, and that column is called the timestamp column. And basically the purpose of the timestamp column is if you perform any insert or any update to any row in that table, it captures the timestamp when this operation is performed. So the timestamp is maintained across the row. And also if we perform any delete, we want that also to be logged. And for that, what happens is this procedure basically creates a tombstone table. That table will have two entries. One will have the two columns. One will have the primary key value of this table, and the other is the timestamp. It basically writes like the primary key value and when was this particular primary keys record got deleted from the database. Now coming to our configuration, on our site A, the hostname is ggate1 and it has its own container database with pluggable database PDB1. On site B, the hostname is ggate2. It has its own pluggable database with container database PDB2. On this side, we have the username as guser1 and the two tables involved here are DEPT1 and EMP1. And on the other side, it is gguser2. And the two tables involved are DEPT2 and EMP2. And the Goldengate process involved here are these things: ext src, pump src, and replicate source. Vice versa, the target site, the process names are here. This is our setup and a bidirectional replication. And please note, when we are configuring bidirectional replication, there are certain considerations. If at all we are using sequences, we need to ensure that we are not overlapping the sequence values. What does that mean? Imagine you are making use of a sequence and you have made use of a sequence value 20 here, and when the Goldengate process captures that and passes it to the other side, and when it tries to insert 20 here, meanwhile on the target side the sequence has just generated value 18, and after 19 if it tries to insert 20 it runs into issues. That is why we should not be having overlapping sequences, meaning if you are making use of sequences from 1 to 10,000 here. Example, you should start with the 10,001 to 20,000 here, something like that. We should not be having the overlapping sequences. Also, in a bidirectional replication, changes propagated by the replicate should not be captured by its extract again. Meaning, just imagine you have inserted a value here into the DEPT1 table with 90 and whatever is the column values, finance, and then the location Houston. Now its corresponding extract captures this particular record and it passes on to the site B, and on site B the replicate rep TGT applies that value here. When it applies, the extract process should not be recapturing this value again and sending it to the site A. So it should not be sending this. If it sends the same thing, it becomes a loop and it causes unnecessary issues. So we need to break the loop, and for us to break the loop there are a few options. The option that I have made use of is tag. For every logical change record that is being applied by a replicate, I tag it, specifying the tag value as hexadecimal value. On one side I think I mentioned 730. Whenever replicate applies the logical change records that it received from the other side, it tags this tag value. So the corresponding extract understands. Imagine a case here, the replicate rep TGT is trying to apply this value, and now it has 0935 as hexadecimal value as the tag value. So when this particular record gets applied on the target side, the rep TGT adds this tag value as 0935, 90 fin and Houston. When it gets added by the replicate here, it adds this tag value 0935 for the logical change record, and the extract is made aware of to not to capture that logical change records whose tag value is like this 0935. So now the extract does not capture, and hence it does not pass on to that other side. This way we are breaking the loop. Also imagine you are adding one more record here, 100 char, and the location is Delhi. So now the extract process captures from site B and it passes on to the site A, and on the site A the replicate process, while applying it tags the value 100 HR and the Delhi with tag value as 0735. So now when it is being applied to the database, the extract process, when it tries to see, it understands, okay, this record with the tag value 0735 is being applied by my own replicate process, and I don't want to capture this to break the loop. So this is one more consideration that we need to take care when making use of the bidirectional replication. I have set the value DB options set tag 0735, and on the extract side I have set this value as ranlag options exclude tag 0735. So this particular thing is tagging all our logical change records that are getting applied by this replicate with this tag, and this particular parameter is helping us to ignore such logical change records not to be captured by this extract. Okay. Now let's check the contents of the tables on both these sides. On PDB1 we have these two tables, EMP1 and DEPT1, and this is created since I ran this procedure already on this side. So if you see the contents of DEPT1, I have intentionally added few records here and no contents on the EMP1, and it has got two tables, EMP2 and DEPT2, and the contents are no records for DEPT2 here and no records for EMPT2 here. So let's go ahead and add a few records on the PDB1. And now let's commit this transaction. After a minute, after a few seconds, it should be propagated to the other side. After a few seconds, it propagated to the other side. So our bidirectional replication is running fine. We inserted on the source or on the on one side G-gate 1 with PDB1, and the data got propagated to G-gate 2 side or EMP22 table. If we remember to configure this automatic conflict detection and resolution, we need to actually run this procedure. I have actually run this procedure on one side. This is the side where I have actually run this procedure, and it has created this invisible column since I ran this procedure. So set call invisible on shows me the invisible columns in this table. Since I have already run this procedure here, it has added this particular table here. Not only that, it even created this tombstone table, DT $_ and then the table name. This is the tombstone table, and this tombstone table contains two columns, the primary key value and when that primary key value's record was actually deleted from this table. So these two columns. So on the other side, let's go ahead and run this procedure, the same procedure, so that it gets the hidden column gets added here, as well as it creates the tombstone table. Okay, procedure now got created, invisible column is on. Now it has actually added this invisible column CDRTS $row. So it adds the timestamp whenever we perform an insert or an update to any of the record in this table. So it even created the tombstone table DT $_DEPT2. So when we run that procedure, it actually did two jobs. One is to add a invisible column, and it also created the tombstone table. Also, the other thing it does is it enables the supplemental logging for all of the columns. What does that mean? If we make any change to this table's record, the extract process, it captures all of the columns values in the logical change record. Now let's create a situation where we create the conflict, and we want to try out these three scenarios. We perform insert on one side, and we perform the insert of the same row's primary key value on the other side, that is insert conflict, and update conflict. We perform the update of the row with the different values on both the sides, and the third scenario is we perform update on one side, and on the other side we try to delete the same record. So for the first scenario, insert conflict, on the G-gate 1, we try to insert primary key value 90 and then the finance Houston for the other column values. And on the G-gate 2, we try to insert primary key value 90 and the other column values are legal and Austin. So let's try this out. And before that, let me add a few more records into the DEPT1 because it is empty as of not much records there. Okay, let's add 10, 20, 30. Let's add from 40. Okay, let's run this on this DPT1. Okay, and let's commit now. We just added few records from DPT ID 40 to 80. After a second or two, it should be coming on the other side also. Okay, since we inserted value from 40, 50, 60, 70, 80 got replicated. The records from 10 to 30 were inserted even before I set up the Goldengate replication. Our insert scenario, we have two scripts. On our G-gate 1, we make use of this script which connects to GG user 1 and PDB1, and it tries to insert 90 finance Houston. And on G-gate 2, it tries to insert a GG user 2 PDB2, and it tries to insert 90 legal Houston, and I have scheduled them to run at on both the sites. I have scheduled it to run at the same time. So we are basically inducing a conflict, insert conflict here. So in a minute it will run, and then we will see what will be the final result. Okay, now let's see the result of it. I can see 90 legal Austin got inserted at 147 from DPT2, Let's run the same thing on DPT1. It got inserted at 147, and the timing shows on both the sides is the same, and the data is also consistent across the sides. We inserted 90 finance Houston and 90 legal Austin, and 90 legal Austin is the final result. And let's check from both the sides what time each record got inserted. We can see 90 legal Austin got inserted on both the sides at 147.01. Okay, I put it here. Now from the G-Gate 1, let's check at what time this 90 finance Houston got captured. For that we need to make use of the log dump utility. Okay, our extract is right into sequence number 3, dir.sc003. Okay. Here it captured the table definition record for DEPT1. And if we see here, it captured the extract on this side has actually captured finance Houston being inserted into this database at this particular time. Let's get this time. If you see here, the extract on this side, G-Gate 1, is actually recognized the data being inserted. 90 finance Houston got inserted on G-Gate 1 at 147.01 at 4:33.131.000 timing. Whereas on the G-Gate 2, the data actually got inserted at 147.01.85.85.11.82.000. So the latest of these two is 147.01.85.11, and the latest image gets reflected on both the sides. We actually had a conflict, but then it makes use of the latest image to be reflected on both the sides. One more point of interest for us to consider is we wanted to understand who actually won or who lost in this conflict, and for that purpose and for us to understand that, we have actually set the flag record conflicts to true in this procedure. We have set this record conflicts to true. What it does is, if there is a conflict, it logs the details of this conflict and specifies who actually won or lost, and in a set of tables. So if you have to see that, we are on PDB1 now. DB apply error messages is the view. It says there is a Okay, it says it found a conflict of type insert conflict, and then it says conflict type insert row exists, and it confirms whether the conflict is actually won or lost here. So on G-Gate 1, the image that we have actually loaded on G-Gate 1, it is 90 finance Houston, but the final image is 90 legal Austin on both the sides, which got actually inserted on the G-Gate 2 side. So the extract here captured, and then it sent it over to G-Gate 1, and the G-Gate 1's replicate has actually applied the 90 legal Austin on the G-Gate 1 side. So it mentions that this conflict has actually won on the G-Gate 1 side because it applied, the replicate is applied on the G-Gate 1. However, on the G-Gate 2 side, we see the same thing, error number, a unique constant violated, since we were using 90 on both the sides. And then it shows the details of the objects involved, and then it shows the operation type. The operation type is insert, conflict type is insert row exists, and then it lost. It could not apply the image on G-Gate 2. It could not apply the image that it captured from the G-Gate 1. So it shows as lost on the applied state, lost on the G-Gate 2 side. So this way we actually can specify whether the conflict won or lost on a specific side. Okay, now let's proceed to another scenario where we want to perform update of the same record on Ggate 1 and Ggate 2 and see how this update conflict resolution happens. So for that, I have chosen this record department number 60. On the PDB1, its value is Ggate 1 PDB1, the value is 60 HR Miami. This is on PDB2, and on PDB1 it's the same 60 HR Miami. Now we wanted to update the same record, update department 1, set location is equal to Chennai, where department number is equal to 60, and on Ggate 2 we want to run the script, update department 2, set location is equal to Mumbai, where department number is equal to 60. For that, I have created this script update. So this script runs as gguser1 and connects to PDB1 and sets location is equal to Chennai, where department number is equal to 60. This is the same thing, Chennai 60. And on Ggate 2, so we are logging in as gguser2 PDB2 and then update to set location is equal to Mumbai, where department number is equal to 60. So let's trigger a conflict by seeing that both the scripts run at the same time. Date is 2235 here, 2235 here. And one more thing is, for the automatic conflict resolution, automatic conflict detection and resolution to happen using the latest timestamp, the timestamp should be the same on both the sides, which is the same for our scenario. So let's 2235. So the script is set to run at 2238 on both the sides, Ggate 1 and Ggate 2. Now let's see its value on both the sides. This is on PDB1. We see that as 60 HR Chennai, PDB1. Final result. Okay, let's go on to the other side as well. On PDB2. Okay, 60 HR Chennai got through on both the sides finally. So let's so this is the final result. Let's check on both the sides at what time it got inserted. Our interest is of record 60, so it got inserted at 5802. Let's capture this time. This is the timing at PDB2. We can verify the same thing on PDB1 also. It will be the same thing, but we can verify. Okay, 60. Okay, 158 23900. It is the same. So capture this value. We have done this Chennai update from Ggate 1. So Ggate 1's gone through, update gone through. So time in dB is this thing. Let's see what's the time in dB from Ggate 2. Now let's open the Ggate 2. Okay, before that let's verify this info extTGT detail. Okay, it has returned to sequence T4. So now let's open that from log dump, this thing. Okay, let's open through it. This is all header only. Now this is the table definition record for DBT2. Okay, its value got converted to Mumbai at 1708. So let's capture this time as well. And from the G gate to the time in dB is the same as like this one, G gate to time in dB is the same thing. So let's capture that. So if we see this thing, both are the same thing in a different time zone. It is 2024 10th October 05, and then it happened at 5 p.m. 8, and then this thing is latest when compared with this one happened at, whereas this one happened at 5:08:02. So this thing is latest, and hence it ignored the update that you performed Mumbai. You performed the update as Mumbai. This is what we can see from the log dump, and this happened at the time 5:08:01:430. Okay, whereas the update from the other side, the G gate 1 update happened at 5:08:02. So using the latest timestamp resolution, the latest update happened is of Chennai, and hence the final result is 60 HR Chennai. This way we can see the details of update conflict. If we want, we can even verify the db apply error messages. Update row exists 1, on this side it 1 pdb2, because it took the update from ggate 1 and it applied on it, so it 1. On the pdb1 it lost. So on the pdb1 update row exists and it is lost. So this is the scenario of update conflict. Okay, if we have to talk about this error message, it says a row with key department number 60 exists but has conflicting columns. Location in table gg user 2 dot department 2 ora 1403 no data found. The reason for this is, on both the sites we inserted the initial data was 60 HR Miami, and on site A we updated it to Chennai, and on site B we updated it to Mumbai at the same time. So from site A, since we have enabled automatic conflict detection and resolution on both the sites, supplemental logging is enabled for all of the columns. So when we make a change on site A, 60 HR Miami is captured as the past image, and 60 HR Chennai is captured as the current image. And when it is propagated to the site B, the current value, it expects 60 HR Miami, whereas the current value on the site B is converted to Mumbai. Hence it considers it as a conflict, because the current image and the site B is not the same as the past image of the site A. So it is considered as a conflict, and hence the automatic conflict detection and resolution kicked in. Okay, going to the another scenario, we want to test update and delete, wherein from one side we will try to update a record, and the same record we will try to delete from the other side. So let's try to do that. On our site here, which is ggate 1, I have this script. Okay, this is trying to delete where department number is equal to 60 from ggate 1, and the corresponding script on the ggate 2 is this thing. dpt2 set dname is equal to finance. We are trying to set the dname as finance for department number 60. Okay, and the time is So we have set this conflict update delete conflict to occur at 119. Let's review the results. This is on PDB2. Okay, on the PDB2 we see it as a 60 finance and Chennai. On PDB1 it is the same 60 finance Chennai. So the update operation occurred later point of time when compared with the delete. (929,175) from PDB1. 929,175. So this is the thing. So if this actually we have performed the update from G-gate 2. That means the delete from the G-gate 1 has actually lost, and we can verify the log of it using the tombstone table. This is the tombstone table created in DEPT1, and if we select from that, we see that record 60 row with primary key value 60 got deleted at this particular time. So let's capture that time. If we compare these two values, 5th October 7:49, this is the time update happened, 1:9:29, and 1:5:33 is the time when the delete happened. So the update happened at an earlier point in time, so the update has actually won the conflict, and record still existed and got modified with the update operation. Just for a scenario, imagine you have some data which is existing on one side alone, and during our initial load we were told that it is fine if this data does not exist on the other side, and we have such data. This is on our PDB1. If we select from DEPT1, we have here 10, 20, 30, and we don't have those three records on the other side. So let's do one operation here. On the side where the data is existing, let's try to perform an update, and update of 10. On the side PDB1, record 10 exists and its values are accounting and New York. So let's try to perform an update here from location from New York to Portland, and similarly on the other side let's try to insert completely a new record. Insert into DEPT2, values 10, admin Las Vegas. So here the record exists and G-gate 1 exists, so we are performing an update operation, and on G-gate 2 the record does not exist. Record with primary key value 10 does not exist, and we are trying to insert it. So let's see what happens. And I have a shell script for the same. Let's schedule it 1:55. We have induced a conflict wherein we are trying to perform an update on one side where the record is existing, and on the other side the record does not exist, but we are trying to insert. Let's see. Okay, the script might have run. Let's verify the result. On the DEPT1, okay, it has changed to admin Las Vegas. On the DEPT2, it has changed to the admin Las Vegas. Admin Las Vegas is the final result. And let's see at what time it got inserted into the DB. So we have inserted that from G-gate 2. Our interest is this thing, 10. So it happened at 8:28:01:656. Timing from the PDB1 will also be the same thing. And let's try to get the result from the log dump. So it is still writing to C4. Let's open it. Okay, this is the detail that it captured in the log dump from New York. Accounting New York, we modified it to Portland. For some reason it did not capture the complete time here. I cannot see it, but we have another way to see on what side the conflict has actually won or lost. So if we see from PDB1 DB apply error messages, we see that unique constant violated for table gguser1.dept1 with column values department number 10. Unique constant violated. And if we see here, in the operation is insert, conflict type is insert row exists, and it is 1 here, meaning the replicate has actually applied the data which it captured from the other side. So that is the reason why on the other side we actually inserted 10 admin Las Vegas, and that is the reason why it got applied even in the G-Gate one. Technically it would have done earlier than this thing, and that's why it got ignored. This thing got ignored, and we actually got the final result as this thing. And we can even verify that on the other side also. Okay, this is for record department number 10, and department number 10 update row exists, and it's actually lost. The change that we have actually done from the G-Gate 1, all that got captured, it could not be applied. It got lost because it was done earlier when compared with the G-Gate 2 change. This is just one resolution method in automatic conflict detection and resolution. We made use of the latest timestamp resolution, and we tested the same with multiple conflicts. And that concludes our video. Thank you for watching.